Hello all. So in the last two sessions we were discussing about the fundamentals of digital circuits, right? So we have started with the basics of digital circuits, and then we have looked into the logic gates, and then we have seen classification of logic gates, and then we have looked into Boolean algebra, and after that we have seen the fundamental concept for any digital logic circuit designing is logic gates. So basically the logic gates are the building blocks to design any digital circuit. Okay. Now before we actually start with designing digital logic circuit, it is necessary that we use gate level minimization. Okay. So when you get a function, it is much required that you have to reduce that given Boolean function such that the number of gates that we use for designing the circuit would be less. So when I say we try to minimize the gate level circuit such that we will be using very less number of components with which the size of the device will be reduced and the functionality or the speed of the device will be increased. So today's topic is all about gate level minimization. Okay. So before we actually start with digital logic circuits, we have already seen that Boolean algebra is used for minimizing the given logic function, right? But we have to understand so many Boolean laws and theorems in order to reduce the given Boolean function. Sometimes even if we are aware of all the laws and theorems, we may not be sure of which particular law or theorem to be applied when the number of input variables increase in the given Boolean function, right? So in order to avoid that complexity, we have started with K-maps, Carnot maps, which are used for reducing the given Boolean function, that is for gate level minimization. So in the last class I have discussed about some basics of K-maps. Today we will continue with brushing off those topics. We'll brush up, I'll give you a quick recap on the basics of K-maps, and then we will see how do we solve minimizing the given Boolean function using K-maps with so many examples today in the class. So let's begin the class. So we are going to discuss about gate level minimization today. Okay. So in the last class we have seen what is canonical form, what are standard forms, right? So POS, product of sum and sum of product functions, and then we have started with K-maps, and as I already told you, K-maps are used for solving the Boolean function with 2 variables, 3 variables, 4 variables, 5 variables and 6 variables, okay, 6 or more. Okay. For our syllabus we will be discussing about 2 variable K-map, 3 variable K-map, 4 variable K-map and 5 variable K-map. Today in this session I would be discussing about 2, 3, 4 variable K-maps, and in the next session we would continue with 5 variable K-maps. Okay. So we have already seen how do we simplify sum of product function and product of sum functions, and apart from these concepts that we have already discussed earlier, the new concept that we are going to discuss today is all about don't care conditions. Okay. This is very important concept in K-maps. So we are going to discuss about how do we solve K-maps with don't care conditions as well. Okay. So let me just give you a quick recap of what did we discuss already in the last session about K-map. Okay. So we have seen that we can minimize Boolean functions of 3, 4, 5 variable easily using K-map without any knowledge of Boolean algebra theorems. Okay. And we have also seen that K-map can take 2 forms, that is one is sum of product and the second one is product of sum. Okay. We have also seen that K-map is a truth table like structure which has some arrays. Okay. It has table like representation which gives more information about the Boolean function that you are taking, and inside K-map cells we would be using zeros and ones. As I already told you, we will be using 1 in the K-map cell when we are dealing with sum of product, and we will be using 0 inside the K-map cell when we are dealing with product of sums. Okay. Let's dive deeper. Yeah. So in the last class we have also seen the steps that we use for reducing the Boolean function using K-maps. Okay. So first we have to select the size of the K-maps depending upon the number of variables. After I do this, we will identify the given function whether it has min terms or max terms, that is whether the given function is either in SOP form or POS form. Okay. So once I select the size of the K-map depending upon the number of input variables, I will be looking after what terms are represented inside the function, whether the given boolean function is in SOP form or POS form. Okay. After that, for SOP we put ones in the blocks, and for POS we put zeros in the block. Okay. After doing this, after representing zeros and ones or the min term or max terms inside the K-map, we will be making some groups, right. So groups containing powers of 2, that is group of 2, 4, 8 and 16. Okay. Now once the grouping is done, we will generate expression for each group. I have already told you how do we group them. There are some rules and regulations that we have to follow when we do grouping, and then how do we generate a boolean expression, okay, boolean function for each and every grouping that we do. Okay. Yeah. So let's quickly look into 3 variable K-map first. Okay. So this is SOP form. So when I talk about when I talk about 3 variable K-map, I have 3 inputs. One is A, B and C. Okay. So as I told you, as we have 3 inputs, we have 8 cells, 2 power 3. For n inputs, we have 2 power n cells, right. So as we have 3 inputs here, we will be taking 2 power 3, that is 8 cells. Okay. So this is how I arrange my cells, and as I told you, please follow the grayscale coding here. So the first cell will be 0, 1, 2 and 3. Okay, or in short 0, 1, 3, 2, 4, 5, 7, 6. Please make a note of this. This is where most of you go wrong. We are following grayscale notation where the adjacent elements will be near to each other. Okay. Now 0, 1 representation, as I have only one input here, I have 0 and 1 representation of A. 0 is A bar, 1 is A. As I have 2 inputs B and C here, I have 4 combinations 0, 0, 0, 1, 1, 1, 1, 0. Look at this, I am taking it 3. So it is 1, 1 and then 1, 0. So 0, 0 is termed as B bar C bar, 0, 1 as B bar C, 1, 1 as B C and 1, 0 as B C bar. Okay. So this is how I represent my boolean function. Why am I calling it as SOP form? Because this 0 represents product term. This 0 represents product term, A bar, B bar, C bar. So this 0th cell is all about A bar, B bar, C bar, that is product term. Hence I am terming it as SOP form. Okay. Now I have put a question mark here. Can you tell me why did I put a question mark here? The reason I put a question mark here is because I am using SOP. I want you to understand. For SOP, sum of product will be using summation symbol. Okay. So Z is equal to summation of A comma B comma C is equal to 1, 3, 6, 7. Okay. Now the question is something like this. Reduce the given boolean function f of ABC is equal to summation of ABC is equal to 1, 3, 6, 7 using K-map. Okay. I am not asking you to use boolean algebra here. I want you to reduce the given boolean function using K-maps. Okay. Now how do I do that? First thing is I will take the basic structure of K-map. As I have 3 input variables A, B, C, I am taking 8 cell K-map. That is step 1. Okay. Now in step 2, my inputs are 1, 3, 6, 7. So in the cells 1, 3, 6 and 7, I will replace ones because this is sum of product. That is the reason I am placing ones inside the cells 1, 3, 6 and 7. Okay. Once I am done with this, now I have to go for grouping. Okay. So before we actually start with grouping, I already told you the guidelines. Let me revise them. Okay. So overlapping of the grouping should not occur. Okay. So once one inside the group is covered, in the K-map is covered, you can't do that again. Okay. Diagonal grouping is not allowed, either horizontal or vertical grouping is allowed. Okay. Now let's look into this. I have second important point is you check for the possibility of higher number of variables that can be grouped. Okay. When you are doing grouping, don't go for 2 variable grouping in the beginning. Check if 12 variable is possible or 8 variable is possible, 4 variable is possible. At the last, if all these are not possible, then go for grouping of 2. Okay. Now in this case, I have only 4 ones, and those 4 ones are not placed properly such that I go for 4 grouping. So I don't have option of grouping 4 terms together. So what do? I go for grouping of 2. Okay. So this red grouping is 1 and this green grouping is 1. Okay. Now I need not do this blue grouping again. Why? Because in this blue grouping, this one is already covered here in the red term, and this one is already covered in the green term. That is, cell 3 is covered in the red grouping, cell 7 is covered in the green grouping. See what happens, you can ask me, what happens if I group it again? When you group it again, you will be generating another variable which is not required. We are trying to reduce the function, right? So when you are trying to reduce the function, don't go for many cell grouping. If you go for many cell grouping, you get more number of terms. Okay. Now what would be the expression after I do this grouping? What do? I generate expressions for every group, right? So when you look into this red group, this is SOP, so we get a product term. Okay. As I already told you, let's see how do we get this product. Okay. So when I talk about this red group, on the row I have A, right? On the row I have A, which is 0, hence I term it as A bar. Okay. And when you look into this red group, it is covering these 2 columns, B and C columns, wherein B and B bar gets cancelled and I have only C. Okay. So as you can look into this, this is B bar, this is B, both of them gets cancelled and I will be left only with C. So my answer for red group is A bar C. Okay. Similarly, when you take this green group is covering this row which is A, hence I take A here, and this green group is covering these 2 columns where I have 1 and 0 for C variable. Okay. 1 and 0 for C variable, hence I take that as B. Okay. So the output of this red group is A bar C. The output of this green group is AB. Now as this particular thing is SOP, sum of products, each group will result the product result and I will sum them. So the simplified expression would be A bar C plus AB. Got it, guys? So let me repeat. Step 1 is choosing the number of cells in the K-map depending upon number of input variables. So in this example we were given Z is equal to summation of A comma B comma C, which is equal to 1, 3, 6, 7. Okay. So what did I do in step 1? As I have 3 input variables, I'll go for 2 power 3, that is 8 cells. Okay. So I'll draw a K-map with 8 cells. Okay. So here I label A, here I label BC. 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. 0, 1, 2, 3, 4, 5, 6, 7. This is step 1. Okay. What do I do in step 2? I will place all the min terms in the functions. As this is sigma, these are represented as ones. So 1, 3, 6, 7. This is step 2. What do I do in step 3? Place ones. Okay. What do I do in step 3? I perform grouping. Okay. 4 grouping is not possible because they are not on the same row and same column phase. Okay. So what do? I go for 2 grouping. So I first group these 2 and then I group these 2. Okay. So what would be the expression for this group? This group is covering this, so it is A bar, and this group is covering these 2 columns where 0 and 1 gets cancelled and I will be left. This is B bar C, this is B C. This B bar and B gets cancelled and I will be left with C. Okay. When I talk about this group, it is A and here it is B C bar. C and C bar gets cancelled and I will have B. Okay. Now what do I do in step 4? I will form the SOP equation from the groupings, that is A bar C plus AB. That is your reduced expression. Okay. So step 1, the number of cells. Step 2, place the number of min terms. Step 3, perform the grouping. Step 4, get the reduced Boolean function with that particular thing. Okay. Now I'll tell you what will happen by this simplification. If I don't do this simplification, let me write the expression for this. Okay. So I have 1 which would be z is equal to a bar b bar c, right, 0 0 1. Okay. Next I have 3. What is 3 0 1 1? That is a bar b c, plus I have 6 which is 1 1 0 a b c bar, plus I have 7 which is 1 1 1 which is a b c. Now the original expression had 4 logic gates, that is 4 terms of 3 variable. Okay. Now which logic gate is used for addition operation, guys? AND gate. So what I do is I design one AND gate where I write a bar b bar c, or I can take a input and take inverters also. Okay. So I take a bar b bar c and then a bar b c, another AND gate, and I'll go for a b c bar another AND gate. I'll go for a b c another AND gate, and all of them are ORed together. All these min terms are ORed together, and for ORing I use OR gate. For addition I use OR gate. So when I didn't reduce, when I have taken the original expression, I need 4 AND gates of 3 inputs each and 1 OR gate. So altogether 1, 2, 3, 4 and 5 logic gates are being used. But if I try to reduce this given expression using K-map, I have my 2 words only, okay, 2 literals only in the given function. Now when I want to design the logic circuit for this, a bar c is 1 2 input AND gate, a b is another 2 input AND gate, and then I am ORing them together. Okay, so I use only 1, 2, 3 gates. Okay, this is a simple function with only 4 min terms. 3 variable function with 4 min terms, where I have gradually reduced the size of the circuit from 5 logic gates to 3 logic gates. Imagine when you are dealing with 5 variables, 6 variable or more number of variables in the given function, you may have a big expression which requires more number of logic gates. So when you reduce this Boolean function using K-maps, your circuit size or digital logic circuit size will be gradually reduced, with which the speed of the circuit will be improved and the number of gates, that is cost, will be reduced and the area occupied will be reduced. That is the reason why we are getting the electronic devices which are very portable, which we are getting at very low cost, and which are performing well in high speeds. Got it? So this is all about your gate level minimization and what is the need for that. Okay. Now let's look into more examples of K-maps. Okay. Now look at this. So before we actually proceed into the K-maps, most of you would be confused about the mapping. Okay, that is most important for you to solve K-maps using Boolean functions using K-maps. Okay, so let me give you some pictorial representations of the steps that we need to follow when we do grouping. Okay, now look at this. Diagonal grouping is not allowed. Okay, so please remember, diagonal grouping, as you see in the first picture, is not allowed in K-maps. Okay, this is incorrect. And only see, when you say, ma'am, when diagonal is not possible, I cannot group it like this, because if there is 1 here or 1 here, you could have gone for a pairing. Okay, but when you do this, this is wrong. If you don't have possibility of pairing, then simply take them as individual terms. Okay, so when you don't have possibility, don't go for diagonal grouping, but please put them as individual terms. Okay, now look at this. Now group of 2, 4, 8 are allowed, but not group of 3. Okay, so here you cannot do this grouping. Okay, but in fact, what do? You can group this 4. Okay, all these things can be done as one grouping. Now you can ask, most probably what we actually do is, I'll tell you. Okay, now look at the board, observe the board only. Okay, now I'll tell you where do we actually go wrong and where does student commits mistakes. Okay, now when we look into this particular example, I have a 3 variable K-map, something like this. Okay, as you can see the board, I have 1, 1, 1, 1 and 1. Okay. Now when you look into this particular example, I can make a group of 4, which is my highest priority. Okay. So I will do this grouping, I call it as group A, and next I am left with this. So you would be confused on what do I do with this one? Do I have to do pairing of this, or do I have to circle this as individual term? Okay. So just remember, try for more number of variable grouping. Okay, even if such kind of overlapping occurs, it is fine, but make sure that you do the grouping of 2 instead of circling it, because grouping of 2 is possible here in this case. Okay, now you would be wondering, why do I overlap? What would happen if I just take a single variable? Okay, let's look into this. Okay, now if I take this will be A, B, C, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, right? Now when I do this particular grouping, look at this. So what would be the output of this particular grouping? This 0, 0, 1, 1 gets cancelled. This 0, 1 and 1, 0 gets cancelled. Okay, I will be left with only one term, which is A bar. Okay, now when I go for this grouping, okay, I am left out with this one. When I go for grouping of 2, what would be the expression? I have this 0 and this 1 gets cancelled. My output expression would be BC bar. Right? So the total expression would be A bar plus BC bar. Okay. This is because I have paired this one with this one. Even if it overlaps, I am having this as empty one, hence I am doing this grouping. If suppose I don't want to do grouping, you say, Mom, I don't want to do this grouping, I want to put it individually. You cannot do this. When you do this individually, what would be the expression? It will be A, B, C bar. So when you are doing single pairing, it is A, B, C bar. That is, the expression consists of 3 input terms. Whereas when I am doing a pair, the expression consists of only 2 terms. That is, instead of using 3 input AND gate, I will be using only 2 input AND gate here. Got it? So try to reduce the expression as much as possible. So check for 4 grouping. If it is possible, go for that. If it is not possible, check for 2 grouping. If it is not possible, then if there are any left outs, we'll go for 1. Okay. Now, Ma'am, how do I consider this? Okay. So when you have this 1, okay, check for the adjacent cells. If any of the adjacent cells have 1 in it which are already paired, that's okay. You can use that for your grouping. Okay. Let's see more examples. You'll understand it more clearly. Okay. Now look at this. Okay. Each group should be as large as possible. That is, as large in the sense it should cover as many numbers as possible. Okay. Now when you look into this, this is wrong. Why is this wrong? Because I have possibility of this 4 mapping, I have possibility of this 4 mapping, right? But what did I do? This is one pair, this is another pair, this is another pair, and this is another pair. So I am doing 4 2-cell pairing, with which I may generate more number of terms. So instead of that, look at this. What did I do? Please look at this. I have this 1 pair, I have this 4 pairing, and as I told you, we can fold, right? So as I have 2 more ones here, I am going for another group of 4, that is quad instead of pairs. Okay. Now the advantage of this, let's see what would be the advantage of this and how did I do that more clearly. Let me draw that for you. Meanwhile, you just observe how is that done on the board. We'll concentrate on this now. Yeah, this is the problem that we have. Okay, so what do I do now? Okay, first I have these 4. I'll go for 1 quad. This is group A. Okay, now I have these 2. I can go with pairing, but I prefer quad. If it is not possible, I'll go for pair. So these 2 can be quadded with what? These 2. So even if these 2 are overlapping, that's okay. I have these 2's which are left. Okay. So I'll go for this quad, which would be group B. Now I have this one left out. Okay, what do I do? Do I take it? See, there are three options that comes into our mind. Whether do I take it individually, or whether I pair it with this, or whether do I go for quadding. For quadding, you might be wondering, we don't have 1 year to quad like this, but we can quad it this way. The adjacents can be folded. Now this will be group C. Okay, so what would happen if I go for quadding? I get each literal with very less number of input expressions. Okay, now let's see the output of this, guys. What would be the output of this? This is A, B, C. So here it will be A bar, A, 0 and 1. Here it will be 0, 0, that is B bar, C bar. 0 and 1, which is B bar, C. 1, 1, which is B, C. 1, 0, which is B, C bar. Okay. Now group A. Group A is covering these two rows. A and A bar gets cancelled, and I have these two columns wherein C and C bar gets cancelled. So the answer of group A is B. Sorry, B bar. The answer of group A is B bar. Now when you look into this group B, okay, this is covering this single row, so I have to take A bar. This is covering these 4 columns where 0, 0, 1, 1, 0, 1, 1, 0 gets cancelled. So the answer is A bar. When I look into this group C, this is covering these 2 rows and these 2 columns. So these 2 rows, A and A bar gets cancelled. In these 2 columns, B bar and B gets cancelled. The answer would be C bar. So my given Boolean function F is equal to A bar plus B bar plus C bar. Look at this. I just reduced the big function into only 3 variables, that is A bar plus B bar plus C bar. If you have gone for one literal or pairing, you would be getting more number of expressions. Okay. My ultimate goal here should be the minimal reduced expression. Did you all get this? Okay. Now let's look into this another example. I have 4 ones here. So if you take 4 ones here individually, what would be the expression? A bar B bar, C bar D bar, A bar B bar, C D bar. What would be this? Here if I take AB, this will be 0, 0, 0, 1, 1, 1, 1, 0, right? So I will have 4 individual expression with 4 variables each. But instead I will go for adjacent folding. Got it? So adjacent 4 corners also can be folded in K-maps. Okay? Yeah. So here are some rules for 2, 3 and 4 variables. This diagonal grouping is wrong. When you have something like this, you can go for this. This has one group, this has another group. Next, zeros and ones cannot be grouped together, either min terms or max terms. Okay? Please make a note of this as well. Okay? And next, here I have only 2 things, so I'll go for a pairing of that. And here I have these 4 ones, I'll go for one quad. I'll not make a pair of this. Instead, I'll make a quad with this 2 and this would be my group 2. Okay. So here this is wrong because I have done pairings leaving the quad. Okay. This is correct and this is wrong. Okay. So here instead of taking individually, I can either fold it in this way or I can fold it in 2 ways of folding is possible. Okay. Now this was all about SOP. What would be the change for POS? POS would be same, but when you observe this, inside we have A plus B plus C. Okay. POS we have sum terms and they will be ANDed together, product of sums. Okay. Already we have discussed this. Okay. Now here it is question mark because I want you to understand that there should be pi. Okay. So for max terms we would be using the symbol pi or capital M, and for min terms we will be using the symbol summation with small m, which represents min terms. Okay. Now look at that particular example. What is the difference that you see here as discussed earlier? Here 0 represents the uncomplimented version, whereas 1 represents the complemented version, right? We have discussed this yesterday in the class, in the last session. Okay. Now when you look into this particular thing, I have f of ABC. let's look into this. F of a comma b comma c is equal to pi of, what are the variables? 0, 3, 6, 7. Okay. Now this, I call this as POS because I have pi here, where each term is called as what? Max terms. Okay. And they are typically represented with capital M. Okay. Now when you look into this particular expression, what do you do? What are the steps? Step 1 is, I have 3 input variables, so 2 power 3, that is 8 cells. I draw 8 cell K map. 0, 1, 2, 3, 4, 5, 6, 7, A, B, C inputs, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Okay. Now when I am dealing with POS, I put zeros for the terms given. 0, 0, 0, 0. Okay. Now after I do that, what is the next step? The step 1 is drawing the cell. Step 2 is placing zeros because they are max terms. And then step 3 is grouping. Step 3 is grouping. Okay. Now how do I do this grouping? There is another question here. Okay. Now when you look into this particular grouping here, okay, I'll go for this grouping. Okay. This is A and I have this 0 left here. So I'll group this. This will be group B. Okay. Or in order to confuse, let's write group 1, group 2, and this is the 0 that is left. Okay. Now, is there any possibility of pairing? I don't have anything here, I don't have anything here, I don't have anything here for folding or doing anything. So there is no option, I just take it as it is. So that would be group 3. Okay. Now what would be the expression for group 1? Here remember 0 represents A, not the complemented version. Okay. Now I have this red group where I have this expression as AB, and I have this another red group which is A bar, B bar. But as it is POS, I take it as addition term, sum term. A bar plus B bar. Okay. So one red group will give you A bar plus B bar, and another red group will give you B bar plus C bar, and that individual term will give you A plus B plus C. This is A, B, C. As it is sum term, A plus B plus C. Okay. So the reduced expression here, F is equal to A bar plus B bar into product of sums, right? A bar plus B bar into B bar plus C bar into A plus B plus C. That is what is written here. Okay. So that is all about your reducing Boolean expression in POS. Okay. We will take the product of these 3 terms and the final expression would be A bar plus B bar into product of sums, 3 literal sums. Okay. So no diagonals, grouping of 2, 4, 6, 8, 16, the number of cells in each group. Group should be as large as possible. Each literal must be in at least one group, if not circle that literal. Overlapping is allowed. Wrap around. What is overlapping? One term. This is overlapping. Okay. 6th is overlapped with 7. Okay. Overlapping is allowed. And if suppose I have something like this, wrap around, turning. Okay. Wrap around is also allowed. Get the fewest number of groups possible. Okay. Now look at this another example. We'll discuss few examples on 4 variable K maps now. Okay. Now f of A, B, C, D is equal to summation of. Now when I look into summation, which is that? It is SOP, right? Sum of products. So I have 0, 2, 5, 7, 8, 10, 13, 15. Okay. So step 1 is I'll draw the K map and I'll place all the ones. 0, 2, 5, 7, and then 8. Look at this, I forgot to tell you. So when we are doing this scale coding, 0, 1, 2, 3, 4, 5, 6, 7, this 3 and 4 rows and columns also will be changed. Please make a note. 3 and 4 rows and also columns will be exchanged. Okay. So 2, 3 here, 6, 7 here. Similarly, instead of writing 8 and 9 here, we'll write 8, 9, 10, 11, 12, 13, 14, 15. Please make a note of this. Okay. Not just columns, but the rows also will be exchanged when you go for 4 variable K map. Okay. Now here, look at this. 0, 1, 5, 7, 8, 10, 13, 15. I have placed ones. Now let's start doing grouping. Okay. So this one, this one, this one, this one will be one group. Okay. Now what would be the result of this group? This group is covering these two rows wherein this P and P bar gets cancelled. Sorry, small discrepancy here. It is PQ representation, AB representation. That's okay. Okay. So these two gets cancelled here, and I'll be left with what? If I take AB, it will be B, and when I go for this, these two columns, C and C bar gets cancelled, it will be D. So my expression is BD. Okay. Now what are the other ones which are left out? One here, another one here, another one here, and another one here. Don't go for pairing of 80 or pairing of 210, or don't go for pairing of 810 and 02. When wraparound is allowed, what do? Instead of pairing cell 02 or 08, or instead of pairing cell 210 or 08, what do? I go for quad. Quad of which cells? Quad of 0, 2, 8 and 10, and this particular quad will give you the output as B bar, D bar. So as this is SOP, I am summing these two product terms. Are you all clear, guys? So this is how I do grouping and reduce the given Boolean function using K-maps. Okay, let's see another example. Yeah, look at this. I have only two ones here. So quadding is not possible. So what do? I go for pair. What would be the output of this? This pair is covering only one column, C bar, D bar. So I will take C bar, D bar as it is, and this pair is covering these two rows, A bar, B bar, A, B bar, where A and A bar gets cancelled and B bar would be my output. When you look into this, only this pair is possible. Here only this pair is possible. Here I am wrapping around and making this pair. Here quad is possible. Here wrap around quadding. Here also wrap around quadding, and here also I am going for wrap around quad. Okay. Kindly look into how did I group the cells in a 4 variable K-maps. Okay, let's look into some more examples. Okay, minimize the following Boolean function f of, see this is how you have to represent it in your examinations. Okay, so f of ABCD is equal to summation of m 0, 1, 2, 5, 7, 8, 9, 10, 13, 15. Okay, so what would be the solution? Given the Boolean expression is 4 variables, so we draw 4 by 4 K map. Okay, we fill all the cells of the K map in accordance with the given Boolean function, and then we form the groups in accordance with the rules. Okay, so this is what I have done. Okay, so cells 0, 1, 2, 5, 7, 8, 10, 13, 15. What is the difference between this problem and the previous problem? I have cell 1 and 9 added here. Okay, so first I go for this quad, 5, 7, 13, 15 as one quad. Next 0, 2, 8, 10 as another quad. Next I have this 1 and 9. Okay, there are two possibilities here. Can you tell me what are those two possibilities? I can quad 0, 1, 8, 9. You can do that. I can also quad 1, 5, 3, 9. Both would be one and the same. The ultimate answer would be change in the input variable, but it is a quad with two variables. Got it? So you can go for 0, 1, 8, 9 wraparound quad, or you can go for 1, 5, 13, 9 as another quad. You can also do this. Okay, both the solutions would be correct. Okay, so with this I have 4 quads, right? So the expression would be something like that. Okay. Next, another example. Okay, minimize the given Boolean function. Look at this. This is another example. Okay, now look at this. What is the difference here? I need not go for quadding. Don't quad 1, 6, 13, 9 and 3, 7, 15, 11 when octet is possible. Grouping of 8 is called as octet. Okay, when that is possible, I prefer 8. If they are not possible, I will go with 4. So far we did not come across octet grouping, right? So here it is possible. Look into this octet grouping. Okay, now cells 1, 3, 5, 7, 13, 15, 9, 11 would form one octet. Now I am left with cell 0 and 8. Don't go for pairing. Okay. Check for the adjacent terms. I'll go for one quad. 0, 1, 8, 9 would be one quad. Okay. Now, look at this expression. How did I get this B bar, C bar? With respect to quad. Okay. Now, look at this quad. It is covering these two rows, A bar, B bar, A, B bar. So, A and A bar gets cancelled. I will be left with B bar. It is covering these two rows where D and D bar gets cancelled. I am left out with C bar. So, it is B bar, C bar. Now, when you look into this octet, A bar, B bar, A, B, A bar, B, A, B bar, all these rows gets cancelled and I am left with these two columns wherein C and C bar also gets cancelled. So, when you are taking octet, you will be left only with one literal. Okay, got it? So, when we go for quad, we will be getting two variable literal, that is B bar, C bar, something like this. But when I have gone for an octet, I got the expression as what? D, that is only single literal. So, that is the reason, as I am trying to reduce the expression as low as possible, as much as possible, I prefer octet, which will give you only one variable expression. Okay. Now, let us look into another example, same example, look at this. Now, here, is this correct or wrong? I cannot go with this like this. Why? Because I have my octets possible, I have my quadding possible. So, I cannot go for this. I have this quad possible. After that, after I complete this quad, I will go for this grouping, this grouping, this grouping and this grouping, right. Now, there is a point here. Now, when you do this quad, even after doing quad, there are adjacent ones left out with which I have to go for pairing, right. There are cases like this also. Okay, this is very interesting. Let me explain you this. Okay, this is not wrong. This is correct. Why am I calling it as correct? Let me explain you. Okay, I have my functions like this, right. Now, what do we do initially? We go for quadding. Perfect. This would work. Okay. Now, I have this one which I cannot group it with anything else. So, the only option that I am left with is what? This pairing. Okay. Now, here the same thing again. This pairing. Here, this pairing. Here, this pairing. When I am doing all these pairings, what you can observe is there is no need of this quad. Why? Because this one is already covered in this group, this one is already covered in this group, this one is already covered in this group and this one is already covered in this group. So, when you have all the ones in the quad covered in the adjacent groups, you are just adding one literal extra which is not required. Hence, we remove this quadding. Okay. Now, there would be two solutions for this. Okay. So, the solution one would be one quad with 4 individuals. 4 individual elements. Solution 2 is 4 pairs. Okay. I want you to sit down, put the expression, check which particular Boolean function, the solution 1 or the solution 2 gives you the less number of logic gates. Okay. This is what I have done. I have simply eliminated that quad here. Okay. Now, this is one example with POS, the same thing I have done here, you can just look into that. Okay. You can just look into one example with respect to POS. Okay. Now, as I told you, these are few examples that we have discussed on K-maps. Okay. Now, there is one small concept which is called as don't care conditions. Okay. Now, let me explain you what are these don't care conditions. Okay. So, some logic circuits, there are some logic circuits which can be constructed in such a way that in some cases for some input combinations the output may not be fixed. The output can either be 0 or 1 based on the user's requirement. Okay. Such cases we term as don't care conditions. Look at this truth table. I have 3 variables x, y, z, and when you look into the 0, 1, 0 input, I am not sure what the output is, whether it is 0 or whether it is 1. In such cases, I put them as don't care conditions. That is, they can be easily adjusted either to 1 or 0. Similarly, in the last but one combination, that is 1, 1, 0, it is x. So, how do we deal with this don't care conditions in K-maps? Okay. We mark don't care outputs in the truth table as x, and that x can be considered either 0 or 1. Please remember, x can also be included in the K-map. that can be either considered as 1 or 0, whichever is convenient for us when we do grouping. If suppose I have 1s and if I have don't care with which I can reduce that 1 to much extent possible, then I will convert that x into 1 in SOP, I will convert that x into 0 in POS. So, as per our requirement, I will convert that don't care condition. Okay, let us look into this example so you will understand it clearly. Look at this. Okay, don't care conditions are represented something like this. F is equal to m of, see this is another notation, sometimes sigma will be represented, sometimes small m also will be represented. 1, 5, 6, 11, 12, 13, 14 plus don't care of 4th cell. Okay, now look at this. This is 0, 1, 2, 3, 4, 5, 6, 7. So, in this 4th cell I am putting it as don't care. Okay. Now, when I am doing this grouping, I find that if I convert this don't care into 1, I can go for a quad. Okay. So, by converting that don't care into 1, I can avoid 2 pairs and make it into 1 quad, with which my expression would be reduced to much extent, right. So, if suppose I have don't care somewhere here, okay, if I suppose I have don't care somewhere here which is not used with anything, then I can simply avoid that particular don't care condition. Okay. Now understand, use don't cares only if you feel they can reduce your expression with other input adjacent ones which are possible. Okay. Now look at this. Look at this. I have 2 zeros here, 2 zeros here. This is what? This is POS, capital M, which is product of sums. Hence I am representing zeros. So I have 2 zeros here, 2 zeros here. If I don't have this don't cares, what do? I put this as one pair, put this as another pair. But what am I doing instead of that? I am considering this don't cares with this and I am making a quad. I am considering this don't cares with this and I am making another quad. Now, don't make all don't cares as quad. Okay, don't try to increase the complexity. Try to reduce the complexity by using them in the way that you require them. Got it? So, I am using these don't cares here to make this pair to quad. I am using this don't cares here to make this square to pad, such that I will be getting a reduced expression. Okay. Now, this is another example, as you can see into this. I am using this don't care for this quad. I am using this don't care for this quad. I am using don't square for this quad. Got it? Another example, yeah, same one. Okay, 3 variable K-map. So, I am using this don't square to make this green square. I am using this to don't square for this square. Now, this I don't need. I will not consider that. I don't want to increase the complexity by just taking don't cares when I don't require them. I am not using this third don't care, but I am using this 4 and 5 don't care for making quad of green and quad of blue. Okay. Got it? Next, last example. Look at this. I have 2 don't cares placed here. Okay. So, first I have this quad 0, 2, 8, 10. Okay. Next, I don't have any possibility of squadding this. Okay. But I can only pair this. So, this 14 which is left out I am pairing with 10 and I am not using any of those don't cares. Okay. So, in short, when the output possibility is not decided whether it is 0 or 1, they will be represented as don't cares. You can include the don't cares in the K-map and use them when you feel the don't cares which are adjacent to the ones helps you to make a perfect grouping which can reduce the number of literals in the given expression. Okay. So, this is all about your K-maps and the don't care conditions which we use in the K-maps. Okay. So, with this we are done with 2 variable, 3 variable and 4 variable K-maps including don't care conditions. In the next section I will be discussing about 5 variable K-map and other simplification with which will be done with gate level minimization. Thank you so much.